Hey there, my name is Kevin Ceballos, and today I'll be presenting on continuous improvement of our CI. So before we begin, let me introduce myself. I am a senior software engineer at SimplePractice. I joined in mid-2021, and I work on the platform team. This means I work on features such as authentication, fraud detection, CI/CD processes, that sort of thing. I've been in the industry for around 9 years now, working everywhere from small startups to large corporations. And in terms of what SimplePractice does, we are a health-based SaaS company that helps therapists, counselors, psychologists, etc. deal care to over 16 million people. Therapists use our platform to help manage their private practice. We currently have over 225,000 health practitioners on the platform. We've been around for a bit over 10 years now, and we are continuing to grow. Our tech stack is Ruby on Rails and Ember on the front end. Ruby on Rails on the back end, Ember on the front end. And in terms of how we use Semaphore, we run our test suite on most of our commits. Currently, we have around 55,000 plus backend tests. 51,000 of these are unit and integration tests. So these are generally quick to run. If we were to run it serially, it would take 3.2 hours. We have 4,000 end-to-end tests. We use Ruby on Rails on the back end, so Capybara is a library that helps us run those end-to-end browser tests. If we were to run these serially, it would take 4.8 hours, so a bit longer for not as many tests. These are notoriously our slower tests. And on the front end, we have 7,000 tests that would run 1 hour serially. We've also noticed that we have 3% growth in our test volume size month over month. So on average, every month, our test suite grows by 3% in terms of number of tests. And as you know, this compounds and over time becomes quite large of a test suite. We use tools like Knapsack Pro to parallelize our builds. We chose this library because it plays well with Ruby-based tests and helps us split and load balance the tests across parallel nodes. And if you see above the graph there, above the chart, we run around 103 CI builds per day on all of our branches. So that's quite a lot. This is only for our main project too. We have other side projects that also have daily builds, but for our main project, we run around 103 CI builds a day. So it's quite a lot of machine time that we use to run all of our tests. Some motivations behind optimization and exploring optimization. So early 2024, we noticed that costs for our CI, monthly costs, were rising rapidly. We initially did not know why, and we were trying to figure out what were some first steps that we could take to diagnose. So we scheduled a bi-weekly meeting with Semaphore and their team to help diagnose and explore potential solutions. We also started a cross-org communication channel on Slack so that we could communicate across time zones. This has proved pretty helpful for us for ad hoc questions that may pop up. And we also performed a detailed audit of each step in our CI process just to find problematic steps that are running too long, longer than expected, areas that we can optimize. So some of the key problems we identified throughout the initial stages of the optimization process were ballooning CI costs, This was shown in the monthly billing. Um, Inefficient CI utilization. Um, During our audit, we discovered that certain areas were not efficiently using caching or being parallelized. And number three, we had a lot of flaky tests. So flaky tests, if you're not familiar, are tests that pass some of the times, but other times they do not pass. This could be like time zone related issues, async behavior, um, stuff like that. We've noticed flaky tests are more prevalent in our end-to-end capybara tests. So yeah, these were the three main issues that we identified and we developed a plan to address. So when we did our audit, we also found several key problems that guided us in our approach. First off, we noticed non-optimal caching of the front-end build. We also noticed that the front-end build step was duplicated across all of our parallel nodes, which is a no-no. You want front end to only build once, and then you in your parallel nodes you can pull down that build and run your tests. Yeah, we as much as possible you want to decrease work that is repeated in those parallel nodes just to save yourself build time. Another key finding, we found that a front-end library upgrade a couple months before our investigation caused drastically increased build time. This was a bit hard to pinpoint. We had to basically trace the commit history to try to find the commit that caused an increase in the front-end build time. We also found and noticed that the entire CI runs on every push, even for like draft PR. So if someone were to push a draft PR and push daily, update commits, work in progress commits, those unnecessarily ran our entire CI. So we tried to think about ways we could avoid that or make the process run the CI build less. And finally, as I mentioned, flaky tests were causing a lot of CI reruns and retries. If you have a process or a rule in your organization to not merge failing builds, you could imagine how disruptive a flaky test would be. So engineers were often retrying their entire CI build to try to get to a green state. And that was obviously causing us to eat up a lot of machine time for our CI, which results in increased costs. So, what was our plan of action to address these issues? We had some short-term initiatives and some long-term initiatives. For the short-term initiatives, we decided to upgrade the front-end build libraries. As I may have mentioned before, we had one problematic library that had a negative impact on the front end build times. It caused it to increase drastically. So once we were able to find that library, we upgraded it to a more recent version, and the issues seemed to go away. We also explored, other libraries, front end libraries, to see whether there were any other ones that we could upgrade and increase the build time. We also made some optimizations to when we actually run the CI. For example, we chose to implement a policy where we don't run the CI on draft PRs. We just skip it. Developers could get around this by manually including a commit message to trigger the CI, but for the most part, it was skipped during draft PRs. We also split up the test suite to fail fast on unit and integration tests. As we've noticed, the unit and integration tests are the ones that run fairly quickly relative to our end-to-end tests. So if we were to split our CI into multiple stages and fail fast on the unit and integration stages before we even think about executing the end-to-end tests, then that could save us quite a bit of time, since we don't need to really run the end-to-end tests until the first phase passes. And this is helpful in those cases where an engineer pushes up a PR that has some bugs in it. Those unit and integration tests fail because they catch the bug, and then the engineer addresses those failing specs and the bug, and then hopefully then the PR is ready to run the entire test suite. So failing fast, basically saves you runtime by not executing the entire test suite every single time. We found the granularity of failing fast on any one step to be too granular, so we decided to fail fast instead on the entire unit and integration block instead of one failing test. So basically, we run the entire unit and integration block, and we report all the failed tests within that block. Once all those pass, we move on to the end-to-end tests. We also utilize the change-in feature in Semaphore to only run front-end tests when the front-end has changed. So thankfully, our file structure has a separate front-end directory, and that's where all of our front-end code lives. So we were able to use the change-in feature provided by Semaphore in our CI YAML file to specify that we only want to run our front-end tests when anything in the front-end folder or directory has changed. So this actually optimized our test suite by conditionally running those front-end tests, and it helped quite a bit. We also decided to build our front end and our back end once in a parent step, uploaded to the Semaphore cache, and then pull down the cache in parallel nodes. This is to prevent each node building the app, which it did for the front end in early 2024. So we addressed that, and we also, to try to address the flaky test problem, we established a new process to quarantine, remove, and resolve those flaky tests. Over the course of last year, we identified and removed around 83 flaky tests. Semaphore actually provides a useful tool. I don't know if it's still in beta, but provide a useful tab within your test insights to identify flaky tests. So we've used that to try to identify tests that have failed on the same commit, I believe. We also try to shift our testing culture to prioritize unit and integration tests over end-to-end tests, as unit and integration tend to run faster and are less flaky. We also tell engineers to try to use the skip CI commit message more often when they don't need to run the entire test suite. For example, if they're just pushing up their code for the day and going home. This next bullet point kind of ties into a longer term initiative that we addressed. So we eventually Dockerized the app for our CI. We had a Docker image, built for deployments, but in our CI we were just setting up the app sort of within the base CI container. And we weren't using any Docker images there, but we decided to go forward and Dockerize the image for CI purposes as well. so that we could build the front end and back end, upload an image on a parent CI step, and then pull it down for all the parallel nodes. And to help with this, we also use the Semaphore container registry. Initially, we were using AWS. We noticed we were paying quite a bit in network costs, so we switched over to the Semaphore container registry to save on costs there on network traffic. And finally, our last long-term initiative was to switch to a different front-end build tool. For the longest time, we were using Broccoli, which is a build tool in Ember that is sort of the default one quite a few years ago. But Embroider is a more recent build tool that has a lot of performance improvements and helped us quite a bit in terms of reducing our front-end build time. So yeah, that's a brief summary of all the different actions that we initially took in early mid 2024. All of these we also addressed by the end of the year. And yeah, this next slide sort of shows some of the month-over-month percentage change in costs improvements that we saw. The star here on the chart is the month that we met with Semaphore and we started sort of optimizing. This was in April of last year. As you can see, the month after that, we had a drastic drop in costs because we were able to identify some quick wins and areas that we could immediately optimize. There were some spikes in July and October. These are just some small issues. For example, in one instance, we may have left a cron job to run specs on that sort of increased cost, and I would consider them anomalies. But in general, the general trend is that the costs have decreased. And something to note, our team size has increased during this period of time, and also our tests have increased 3% month over month over this time. So overall, we're still we dropped in price in month over month costs over this time, despite having growing team and growing test size. Some future steps, optimization is a continuous sort of cycle. We don't expect it to ever stop. There's always going to be some improvement, some new advancement in technology that will help us optimize further, make our test suite run faster, that sort of thing. So we're always, continually trying to improve there. We also have to keep in mind that CI optimizations, we need to balance that with more impactful work in our org and company priorities. As many of you may know, CI work is probably not at the top of the priorities for most companies. They until they start to see costs rise. For the most part, they like to focus on product focused, features. So consider the opportunity costs of your optimizations and whether it's worth optimizing at your current scale. For example, you don't want to over optimize when your test suite is still super small. For example, you don't want to spend or waste a month trying to investigate an optimization that will only save you guys hundreds of dollars. And it may make more sense to wait until your month could be dedicated to solving a problem that can save you guys thousands of dollars over the course of a couple months. So try to evaluate whether it's worth optimizing and which sort of things you optimize. Further steps, we want to explore using Qprite. I hope I'm pronouncing that correctly. This is a Ruby sort of tool, Ruby-based tool that I believe moves away from using Selenium for our end-to-end tests and uses a headless browser. People have noted that there's quite a bit of a speed up that they experience when switching to Cuprite over the default Selenium WebDriver that most Capybara setups are set up with. So we are exploring that. We're also exploring using Datadog's test impact analysis tool. So this tool is supposed to help you conditionally run your unit tests based on files that have changed. So let's say you have a PR up that changes 4 Ruby files. This tool would only run the tests that those 4 Ruby files impact. It seems very promising. We haven't actually dedicated that much time into implementing and investigating this tool, but if it works, then that would also save us a lot of CI runtime. And finally, we are exploring only running our slower and flakier end-to-end tests only before release. So we are essentially, some orgs do this, and it's not too conventional, but maybe once you get to a certain size, it starts to make sense. We only want to run the end-to-end tests on the branch, our release branch, right before release, to make sure that those tests pass there. This would be in contrast to running them in every single PR and every single commit that is pushed. So to summarize, we are continuing to iterate and optimize. We're trying to maintain a stable cost relative to the team and test suite size and growth. And we acknowledge that there are always going to be unavoidable sequential workloads that we can't parallelize, and we must be strategic in the areas we try to optimize. There's a sort of law for this called Amdahl's law, I believe, where there's a formula basically that tries to guide you in, what areas you should optimize and what areas you should parallelize. And this formula actually takes into account the fact that there's unavoidable sequential workloads that you'll always face. So yeah, I just wanted to end this presentation there. Thanks so much for your time. Thank you.